Welcome back. Let's continue. Let's start with our concept map. We are doing a 2D shapes and we'll start with identifying triangles. Identifying triangles starts with the size of triangles, of angles in the triangle. The first one is an acute angled triangle, which is made up of 3 acute angles which are less than 90 degrees. So that's what we would call it, an acute angled triangle. We look at the next one, which is an obtuse angled triangle, which is the triangle itself has one obtuse angle, and that angle will be between 90 degrees and 180 degrees. Then the third one is a right angled triangle. One of those 3 angles is a right angle, which equals to 90 degrees. Let's then measure that triangle FGH using the protractor. Let's go find the protractor. We found the protractor. I said I'm using online protractor. The first pin is where at angle 0, where the angle begins, and the next pin is where the angle ends. So in this case, because it's a triangle, first pin will be on the bottom side or the side where I want to begin measuring, and the last pin would be on the side where that triangle, the side that I want to measure. And for me, it then gives us 60 degrees. Let us move the protractor to measure angle H. Let's move the protractor to the other side. There's a pin, and the next pin is on line, and we get again 60 degrees. So which then says all 3 angles would give us 60 degrees. That's what we're hoping to get. So let's tilt it over and check. Let's move the protractor. There. Let's pin it down. And it gives us there. It gives us 60 degrees. So now we know that we have a triangle that has 60 degrees of all 3 angles, and we call that an equilateral triangle. So now we know that triangle FGH is an equilateral triangle. All 3 angles are equal to 60 degrees. Let's move on to the next one. The next diagram is we are to measure the angles of triangle RST, and we name that triangle. There are the angles there. The first one is 22 degrees. As you can see, I've put my pin. Now I'm all of a sudden using the black line because I'm measuring from the left-hand side. That's where I'm beginning. And then after measuring that, that gives us 22 degrees. And then we move the triangle to the other side, and we find that it gives us pin there and a pin where the triangle ends, and it gives us 89. Find the exact spot there, and it should give us 90 degrees because that's where the angle ends there. Then we move to the next one. The next diagram is we are to measure the angles of triangle RST, and we name that triangle. There are the angles there. The first one is 22 degrees. As you can see, I've put my pin. Now I'm all of a sudden using the black line because I'm measuring from the left-hand side. That's where I'm beginning. And then after measuring that, that gives us 22 degrees. And then we move the triangle to the other side, and we find that it gives us pin there and a pin where the triangle ends, and it gives us 89. Find the exact spot there, and it should give us 90 degrees because that's where the angle ends there. Then we move to the next one, the third one. Tilt the triangle over, the protractor over, move it to where the angle begins. Put a mark where it begins. And a mark there. So this one gives us 68 degrees. So now we have a triangle that has 90 degrees, 68 degrees, and 22 degrees. And because the three angles are different, but one of them is 90, we call that a right-angled triangle. Right, let's change and measure the next one. The next one, we are to measure the angles of triangle JKL. And as I measure the first one, I'm using the black markings and it gives me 70 degrees. Remember, you always start from 0 when you measure and you increase with the numbers. Because if you read it from the blue one, it says 110, but we're not measuring from the right, we're measuring from the left. So it's important to remember which side you're starting from. So it gives us 70 degrees. Then let's move it to the other side. And there it is. Again, it measures from, put the first pin, and we put the next one, and it gives us 70 degrees. It's not exactly, it's 0 there. So it gives us 70 degrees. So this time, because we're measuring the triangle on the right-hand side, we start from 0 to 70, and it gives us 70 degrees. So we've got a triangle that has two angles at the bottom that are equal. So that is an isosceles triangle. That's how we measure them, and we are able to then take that information and use it even when we calculate. I hope now you understand how we use a protractor. Let's continue with our lesson and look at our concept map, the next part, which is distinguish between triangles. The first one is an equilateral triangle. We said it has all sides equal and all the angles are equal to 60 degrees. We've seen that for ourselves. And then the next one is a scalene triangle. And as you can see with the markings, they are not the same. Therefore, all the sides are not equal. And that's what we said there. And then the next one is a right-angled triangle, which means that in the triangle there is an angle that is 90 degrees. And that is the only angle that would be 90. The others are acute angles. Here's an example. Let's look at that diagram together. The first question says, identify one equilateral triangle and state why. Look at the markings on the diagram, and triangle PST there, I will just highlight it so that we can see it. Triangle PST has 3 markings that prove that these are equal sides. Therefore, our answer there would be triangle PST, and our reason would be all 3 sides are equal. Now let's look at the next one, and it says identify 2 isosceles triangles and state why. Remember, an isosceles triangle, we're looking for 2 equal sides. There is an equal side there and there. Therefore, triangle STR is an isosceles triangle. But then there is triangle PST also has 2 markings. Therefore, though it is an equilateral triangle, it's also an isosceles triangle because it has 2 sides that are equal. Therefore, and triangle PST. So now we know that we're looking for those 2. Let's look at the next one, which is find 2 right-angled triangles. Of course, these ones, we just go to the triangle and look for the right angle. It is in triangle, there is the right angle there. So it is in triangle QSR. So it's triangle QSR. And the other one is there. So that would be triangle STR and triangle ST. QTR. So those are the two triangles that have right angles. In question D, we are to identify two scaling triangles and state why. Let's look at those at the diagram. You would see that PTQ, P to TQ, that is a scaling triangle. All the sides are unequal. And you look at, again, QTR, that is again another scaling triangle, and the sides are unequal. So it would be triangle PTQ and triangle TRQ. Those are the two triangles that are there. And as you look through it, you could see that also triangle PQS is another scaling triangle, as well as QSR. Those are also scaling triangles, but then they asked us to only identify two. For now, let's stop there and go for an ad break. See you shortly.